preloading shaders. Stop freezing your players mid-gameplay. Hello and welcome to episode number 31 of the Unity Performance Task Force podcast. I'm your host Ruben from TheGameDev.Guru, and as usual I'll kick things off with a question for you. Have you ever been playing Counter-Strike, lining up the perfect headshot, and then your game freezes for half a second because Unity decided right now is the perfect time to compile a shader? Sounds familiar? If so, this episode is for you. Today we're tackling shader compilation, not the kind that happens in the editor while you sip your coffee. The kind that happens at runtime, on your players' machines, freezing their gameplay at the worst possible moment. Let's set the stage. In the Unity editor, life is easy. You assign shaders to materials, Unity compiles them in the background, you don't think twice about it. But that's editor magic. It's hiding complexity from you. And when Unity hides complexity, you become unaware of the costs that hit later, when your players actually load your game. Here's what happens at runtime. Unity compiles shaders against the target platform's drivers and GPU. Quest shaders look different than PC shaders look different than Android shaders. The compiled code varies by hardware. And that compilation, it takes time. Sometimes half a second, sometimes 10 seconds. I've seen both. So when do you pay this price? Two ways. First, the bad way. Unity compiles shaders on demand, the moment an object using that shader appears on screen. Unpredictable, frustrating, game-breaking. Second, the better way. You compile shaders at specific points in time that you control. Loading screens, splash screens, anywhere your players expect to wait. You increase load times, but you avoid mid-gameplay freezes. Let me be clear. Not all shader compilations are a problem. If you allocate the shader once at startup and keep it forever, that's fine. The problem is when you compile shaders just in time, during active gameplay, without warning. Why does this happen? Two conditions. First, the shader variant hasn't been compiled yet. Second, an object using that variant appears on screen. Boom, compilation, freeze. Your player's immersion is shattered. Here's the two-step approach I recommend. Step 1. Detect which shaders are being compiled at runtime and when. Step 2. Preload them at safe points where freezing doesn't matter. Let's start with detection. You need to enable log shader compilation in your project settings. Go to Edit, Project Settings, Graphics. Scroll all the way down to Shader Loading. Check the box for log shader compilation. Now build and run your game, not in the editor, on your target device. Deploy to Quest, deploy to Android, whatever your platform is. Then check the player log. On desktop, that's in App Data Local Low. On mobile, use ADB Logcat. Search for compile shader. You'll see entries with the shader name, the stage, vertex or fragment, and the keywords. Each combination of stage and keywords is a separate shader variant. Each variant gets compiled separately. If you use ADB Logcat, you'll also see timestamps. That tells you how long each compilation took. Now you know which shaders are the culprits. But detection is only half the battle. Now you need to preload them. Here's the workflow. First, go to your scene. Walk around, look at everything. Unity tracks which shaders appear on screen. That's the currently tracked section in the graphics settings. In my test project, I had 46 shaders tracked, 48 variants total. Once you've seen all the content you want to preload, click Save to Asset. This creates a shader variant collection. It's just a list of shaders and their variants. Save it to your Assets folder. Now you have two options for preloading. Option 1. Manual control. Write a script that references your shader variant collection. Call the warmup method on start or whenever you choose. Unity compiles all those shaders in one go. Let me walk you through the code. Create a script, add a public field for the shader variant collection, assign the reference in the inspector. In your start method, call mylistofshaders.warmup. Done. Build and run. Check the logs. Now you'll see all those shaders compiling at startup, not during gameplay. You move the pain from unpredictable to predictable. That's a win. Option 2. Automatic preloading. Unity can compile these shaders before the first scene loads. Go to your shader variant collection asset, check Preload shaders. Unity will block on startup until they're all compiled. But wait, there's more control. You can tell Unity to preload after showing the first scene. You can even set a per frame time limit. If you have 1,000 shaders, Unity won't freeze for 20 seconds. It'll spread the work across multiple frames. Maybe 10 shaders per frame. Choppy, but not frozen. This feature is relatively new in Unity. I needed it on a past project. It wasn't there yet. But now it is. Use it. Now here's the bump. The shaders Unity tracks in the editor aren't always the same ones your target platform needs. Quest needs different keywords than PC. VR projects need different keywords than flat screen. The editor might track a Windows XR variant. Quest doesn't need that. Quest needs an Oculus XR variant. If that's the case, you're preloading useless shaders, wasting time. What do? You edit the shader variant collection manually. It's a text file. Open it in a text editor, remove the variants you don't need, add the variants you do. For example, if Quest forces HDR off, but the editor tracked HDR on, delete the HDR on variant, keep HDR off. This is finicky work. You need to know your platform's requirements. But once you do, you have full control over what gets preloaded. At TheGameDev.Guru, we've done this for multiple AAA mobile projects. It works. The key is knowing how to detect and measure the costs, then preload at the right moment. Here's your action plan. First, enable log shader compilation in your project settings. Second, build and deploy to your target device. Play through the game, check the logs, see which shaders are compiling at runtime. Third, go back to the editor, walk through your scenes, let Unity track the shaders. Fourth, save the tracked shaders to a shader variant collection. Fifth, write a script to call warmup at a save point. Loading screen, splash screen, anywhere players expect to wait. Sixth, build again. Confirm the shaders are now compiling upfront, not during gameplay. Bonus step. Open the shader variant collection in a text editor. Verify the keywords match your target platform. Remove anything you don't need, add anything you do. Let me recap the 3 most important takeaways. 1. Shader compilation at runtime causes unpredictable freezes. Players hate this. Move compilation to predictable moments like loading screens. 2. Use log shader compilation and the currently tracked shaders list to identify what needs preloading. 3. Shader variant collections let you control when shaders compile. Call warmup manually for maximum control or use Unity's automatic preloading with per frame budgets. One more thing. The shaders Unity tracks in the editor don't always match your target platform's needs. Check the keywords. Edit the collection manually if needed. It's extra work, but it pays off. If you're suffering from freezes and long loading times, make sure to diagnose when shader compilations are happening. You want them to happen at one point where it's not a problem, not during gameplay. If you found this podcast episode useful, you can access in-depth lessons in the Unity Performance Task Force program at www.performancetaskforce.com. And if Unity Consulting is what you are after, book a free discovery call at http://consulting.thegamedev.guru. Till next time.